This video will cover a quick introduction on limits. In math, we say that a limit is going to be the output value that a function approaches as an input approaches a specific value. Another way to think about it, to make it simple, is what is the y value of the function as it's approaching a specific value, and this is going to be the approach to that specific value of x coming from the left or coming from the right side. Let's look at example 1. This is how we write a limit. We have the limit of the function, so we have limit as of function f of x. We don't know exactly what the equation of the function is, but you are trying to figure out what is the y value as x is approaching -4. So if we look at our graph at -4, and I'm going to use the color red so you can see it. From the left side, this function is going to be approaching 4. That is the y value. From the right side, you also see that it's approaching 4. So in this case, the limit of the function is going to be 4. So the limit does exist, and we're going to say that this limit is 4. Let's look at the same graph, but now we're going to be paying attention as what is the limit as x approaches -7. Now, you can see clearly that there's a hole. There's a hole at -7. So if you were given a function and I tell you input -7, you will get an error. You'll get something undefined. So this is not equal. So this is not equal to -1. But now we're paying attention to the behavior of the graph. So from the left side, what number is it approaching? We can see that from the left side to -7, we get -1. That is the y value. And from the right side, it's approaching the same value. So we say that the limit of this function is going to be -1. Now, we know that at that specific value, we have a hole and the function doesn't work, but the limit is going to be -1. For example 3, we're going to be looking exactly the same graph. But now we're looking for x is approaching 8. Now this is where it gets a little bit interesting, because you have, in this case, 3 points. We have one that is a closed circle and you have 2 open circles. Now, if you were giving a function, an equation, and you put f of 8, we know that the answer for this is going to be -1. So that is true. But if we're paying attention to the graph to see the limit, we need to see it from the left and to the right. So as we follow this line, you can see that this section of the line on the left side is approaching -3. So we're going to say the limit as x approaches 8 from the left side, from the negative side, is going to be equal to -3. Now, if we look at the limit as it's approaching from the right side, so if we look at this line approaching from the right side, this is actually approaching -5. So we will say that the limit as x approaches 8 from the right side is actually going to be -5, because these two are not the same number. We say that the limit for, in this case, does not exist. So in this case, the limit does not exist. For example 4, this is slightly different. In this case, you see how we have a rational function, and this graph is starting right here, and we see that there's no holes. So this line is continuous, but we have an asymptote right here at -4. and we have another asymptote. If we pay attention and we're looking for -4, and we said you pay attention to it's coming from the left and from the right. So that means that if we look at the limit as x approaches -4 of f of x, but we're going to pay attention to the coming from the left side, we see that this is going up forever. So we see that this is actually increasing. It's not going to a specific value. Now, if you look at the limit as x approaches -4, but now we're going to pay attention to the positive side. So it's coming from the right side. You see that this is going to go to the negative side. So in this case, first, we know that it's not going to a specific y value. We know that infinity is not a specific y value. That is just a notation. So in this case, because you see that they're going to opposite sides, it's not going to the same specific value, we're going to say that the limit does not exist. For example 5, we have a more simpler graph. We have a line, and we say that this line is not continuous at this point, because in this case we have a hole. So similar to the previous ones, you do have a function that is defined. So that means that if you put -3 into this function, you actually get a y value, which is going to be -4. But if you look at it from the left side, you see that from the left side, as you're approaching 3, the y value is going to be -3. And from the right side, as you're approaching -3, once again, it's going to be -3. So in this case, this is perfect. We have a limit that does exist, and it's approaching the same specific value, and that's going to be -3.